So the next representation we talk about is the processes. So what happens is if you take a part of the event, okay, and so categories of events with the property where if we take a small interval of the event, right, and then see what happens there, okay, that is called a process, okay. So any process E that happens over an interval also happens over the sub-intervals, right? So it is happening continuously from one point to another, right? So suppose we have a process called E and happens E at between T1 and T4, and we have T2 and T3, which is interval which is there within the interval T1 and T4. Then the event is happening also between T2 and T3, right? So that's what we mean by processes basically. Okay, now how do we represent time intervals? Okay, so we just saw how we are using time T1, T2, etc. earlier, right? So what is done basically is you start off with something as the base. Okay, so something like you take January 1, 1900, okay, as the base time. So you take it as time 0, right? And any time after that you can convert it into seconds. So suppose time at AD 1900, seconds will be 0. But if you take time at the beginning of AD 2001, this will be the seconds. So you can convert everything to seconds and then you can sort of compare them or have them relative to each other, etc. Right? Or you can use a function called date which takes the actual date into account. Okay, and it will have 6 arguments: hours, minutes, seconds, day, month and year. So something like this. Time begins AD 2001, at which time you are taking hours, minutes, seconds 0. And when you say date is 0, 20, 21, etc., you can get the seconds in terms of that date. Another thing is if you consider 2 intervals, there are things like do those 2 intervals intersect each other, do they meet each other, etc. Right? So here we can talk about these things. When you say 2 intervals I and j, okay, meet each other, it means the end of interval I is the beginning of interval j. Before, if I comes before j, then we can say end of interval I is occurring before the beginning of interval j, and similarly after ji, okay. During ij, it means that beginning of j is less than beginning of I and end of I is less than end of j. And if they overlap with each other, it means beginning of I is less than beginning of j, which is less than end of I, which is less than end of j. And begins ij, so which means that they begin at the same time, finishes, they end at the same time, equal. So beginning is equal and the end is equal. So you could use these predicates. So meets reign of George the Sixth, reign of Elizabeth II, overlap 50s, reign of Elvis, begin 50s equals begin AD 950, etc. Okay. So these are some ways of taking care of time in some way. The next thing we talk about is the mental events, right? So it means what do you know, it uses things like beliefs. So what does the agent believe? You know, those type of things. or what does the agent know, what does he want, what does he intend, etc. Okay, so these are all mental events which you take into which you take into account, right? So it's something like knowledge about one's own knowledge, okay? So you, like one agent should know what the other agent knows, okay? Besides knowing what he knows himself, or what the other agent believes, right? So you need a model of the mental objects in somebody's head, right? So that is what we are actually talking about here. So, what is in somebody's mind usually is these type of predicates like believes, knows, wants, intends, informs, etc. Right? So if you want to show that Lois knows that Superman can fly, you will have to say knows Lois can fly Superman, right? Um, so usually can fly Superman will be a sentence, but here you are using it like a term, right? So that's what happens when you go to the mental events basically. You should also be able to conclude by using this type of thing. Okay, so suppose Superman equals Clark and knows Lois can fly Superman, right? Then you can infer from this that knows Lois can fly Clark, right? So here what you are doing is you are inferring the facts from these. So if the agent knows 2 plus 2 equals 4 and 4 less than 5, then we want the agent to know 2 plus 2 is less than 5, right? So that type of thing. Okay, so those are all the knowledge representations that we spoke of. So the next part of this session will be on what is called non-monotonic reasoning. Okay, so whatever we have done up till now works on what is called the monotonic reasoning, right? So when we say that a particular knowledge base 1 entails some sentence alpha, right? Now suppose I add more facts or more knowledge to this so that I get something called knowledge base 1 plus knowledge base 2, right? So I've added more stuff into it. If this also entails alpha, okay, then you say that what you are using is monotonic reasoning, right? So when something is true, it continues to remain true for the rest of time beyond that, right? So that is what we use in our data structures, etc. Okay, when we say A is equal to 5 or something, okay, so that is the monotonic logic that we are using. But what happens is there are some reasoning methods where it doesn't remain the same, right? So you can retract something which, so you can say if P is true at a particular point in time, at some other time later on, P may become false, right? That's possible. So why do we use this retraction over here? Okay. What happens is you don't want to keep it in mind, first of all. Secondly, the world may have changed. And thirdly, you may have assumed something is true, but then you found out it is false. So you need to then take it as false. Okay. So how do you carry this out? You are saying that you are going to retract it. So you have said P is equal to true and in a particular knowledge base P. Then you have to use the command retract from the knowledge base P, okay, to remove P from the knowledge base. But if you are removing P from the knowledge base, is it enough just to remove only P? Okay, for example, you may have something like P implies Q, right? So if your knowledge base has P as true and it also has Q as true, then you need to remove Q also from the knowledge base, right? And suppose you have something which says R implies Q also, right? Then what happens is that if R is true and even if P is retracted, you will not remove Q. Okay, so what happens is that it requires a lot of bookkeeping, right? So when you retract one statement, you cannot stop at that point. You have to go through the entire knowledge base to see what can be included and what can be removed. Okay, so doing this is what is known as the truth maintenance. Okay, so that's the truth maintenance. You have what is called the truth maintenance system. So when you have a system where facts can be retracted, you have to use a truth maintenance system. Okay. So now we talk about two ways, okay, two types of logic which is used. The first one is conscription and the second one is the default logic. Okay. So what happens is that, like I said, when the knowledge base 1 plus knowledge base 2 does not entail alpha, okay, when knowledge base 1 before entailed alpha, then you say that it is a non-monotonic. Okay, something which was true before is now not true, right? So when non-monotonic non-monotonicity is there, then there are two types of logic. One is called conscription and one is the default logic. So let's see how these two actually work. So when you take conscription, you use a predicate called abnormal 1, right? So when we say bird X, okay, we can say bird X implies flies X, right? But we know that there are some birds which can't fly. Okay, so you say bird X and if it is not abnormal X, then flies X, right? So we say that abnormal 1 is to be circumscribed. Okay. So unless you know that abnormal 1 of X is true, you take it to be false and therefore the bird can fly. Okay. So for example, suppose you take bird Tweety, right? But you don't have abnormal X, abnormal Tweety is not there, right? So it's not abnormal 1 X and therefore you can infer that Tweety flies, right? So this is what is called the circumscription. But if you have something like say ostrich or a bird which does not fly, then you are going to have it as abnormal. Abnormal 1 of say ostrich will be true. And therefore it will not be able to fly. So this is what is called the circumscription. So for circumscription, one model is preferred to another if it has fewer abnormal objects, okay? Because there may be some type of clash happening over there, okay? That is, you have multiple inheritance which happens, okay? For example, if you say Republican Nixon and Quaker Nixon, okay? And you have two statements like this, Republican X and not abnormal 2X means not pacifist X, and Quaker X and not abnormal 3X implies pacifist X, right? So you have, depending on this abnormal quantity that you have here, it can be either pacifist or not pacifist, right? So in one what happens is that either one or the other has to be true, okay? Either abnormal 2 of X, if it is true, then abnormal 3 of X should be false, etc. Or you need to have what is called the prioritized circumscription, to give preference to models where abnormal 3 is minimized, etc. So next we come to what is called the default logic. So we can see actually that all human beings work on the default logic. So we have some default values in our mind. For example, if you are going to somebody's house, uh, you assume that everybody likes flowers, so you can take flowers and you can go give them flowers, right? So that is the default logic which is there. But what happens is, if you realize after going there that the person is, say, allergic to those flowers, and therefore giving flowers is not a good idea, you are going to update what you have in your mind. Okay, so you are going to say that generally the default is that people like flowers, but this particular person doesn't like flowers, right? So that is the type of reasoning which we use. So in default logic, the rule looks something like this. Okay. So bird X flies X. So what does this mean? That this rule means that if bird X is true, okay, and if flies X is consistent with the knowledge base, then flies X may be concluded. Okay, so you need to see that. In general, it will be like this. You have justification 1 to J1 to Jn. Okay. So in this case, you will have to have something like Republican Nixon and Quaker Nixon. Republican X implies not pacifist X, if not pacifist. So if this is given in your knowledge base, then you can take that. Otherwise, you take this. Okay, so this is how the default reasoning will actually work. So we can see that human beings use default reasoning. So actually whatever information we have about anything, especially when we make decisions, we don't have all the information about the domain we are trying to take a decision. But what we do is we take the decision with whatever information we have, and we use default reasoning for some of it. In other words, we say this is usually the case. So this is the default reason, this is the default that I am going to take. So when you talk about a vehicle, by default you will assume that it has 4 wheels. Okay, when you talk about an auto, you are going to assume it has 3 wheels, etc. Right? So that is the default reasoning that you are actually using over there. So when you say my brakes are always okay, it means what you are trying to say in default logic is something like this. The probability that my brakes are okay given no other information is sufficiently high so that I start driving without checking them. Okay, so that's exactly what you do in default reasoning, right? Okay, so we talked about truth maintenance, right? So how do we carry out the truth maintenance? So this part actually has been taken directly from the Russell and Norvig basically. So it's something like you want to retract, say, P from the knowledge base. So how do we retract P? We went into that where we said that we don't know if you have something like P implies Q and you retracted P. So if you have P implies Q, then you need to retract Q also, right? But if you also have something like R implies Q, R implies Q, then even though P is retracted, you will not be retracting Q. So one truth maintenance system here, the simplest one, what it does is that suppose you retract Pi, you are retracting Pi from the knowledge base, you look at all the inferences that have been derived from Pi, from the sentence Pi plus 1 till Pn. Okay, so the sentences which were derived before Pi was introduced, you don't have to worry. You only see the sentences from Pi plus 1 to n. So that reduces the speed, that increases the speed to some extent. The second method is what is called the justification based truth maintenance system. So what do you do in the justification based truth maintenance system? If every time you have a statement, okay, for example, what you do is, if the knowledge base already contains, say, P implies Q, if the knowledge base already contains P implies Q, okay, what you do is that you are going to, for P, for Q, you are going to have the justification which says P and P implies Q. Okay. So whenever you find that any statement is retracted, for example, if P is retracted, you see for every statement in the knowledge base, what is the justification, and if the justification has P that is involved in it, then you retract those. So this is what is called the justification based truth maintenance system. Okay, so let us look at another truth maintenance system where every sentence in the truth maintenance system is either in or out, okay, at a particular point in time. So if we take P, maybe at the present time P is in, okay, but at some other time P may be out, okay. So at every point in time, if you take all the nodes which are there, or all the statements, the statement can be either in or it can be out. So what happens is that you will have a lot of statements where some statements are in and some statements are out. So whenever a statement becomes out, it is not removed from the knowledge base, but it is just kept in mind that it is out at this particular point in time. And in nodes have at least one justification which is currently valid, and out nodes do not have any currently valid justification. So there are two kinds of justifications. So one is what is called the support list, which has in nodes and out nodes, right? So if your in nodes, if the in nodes here are in and the out nodes are out, okay, then your support list will be in. And if you take the conditional proof is valid if the consequent is in, whenever in hypothesis is in and how out hypothesis is out. So let us take this particular example of the truth maintenance system, right? So a very small piece of code is given over here. So here we have the first statement says it is winter, okay, and that doesn't have anything in the support list. Second statement says it is cold, and it is cold will be true if 1 is in and 3 is out, right? So the 3 says it is warm, okay. So node 2 will be in if node 1 is in and node 3 is out, basically. Then how scheduling a meeting, how would you do? First you take day of the meeting M is equal to Wednesday, okay, which has to have the 2 to be out, okay. So at the present either 1 is out or 2 is out, or 1 is in or 2 is in, okay. So let's say 2 is out, so we are going to consider this, okay. But suppose you find some other conclusions, and from that conclusions you know that it is not possible to hold a meeting at 2 o'clock on Wednesday, right? For example, time m is equal to 14 hours. So you find that there is some, these nodes have to be in, but suppose you find some of these nodes are not in, then you say contradiction 1 3, right? So you find that 1 3 has a contradiction. So when you have 1 3 having a contradiction, then the system adds a no good node, okay, representing the set of inconsistent assumptions, okay. So because of this, what happens is the node 1 will become out. So when node 1 becomes out, then node 2 will be in, okay, and it will make 4 out, okay, and then the contradiction is resolved. So you are getting a new thing which says day m not equal to Wednesday, okay. So this is how truth maintenance system is actually carried out in some particular cases. So that is a thing. So we'll stop at this point in time, this session, and in the next session we will take up a few more details about representation schemas, for example semantic nets, etc. So we'll stop here.